Thanks.
Okay, there you go. Go ahead.
Okay. So firstly, we would have a quick review on the release 11.2022 of XGVela. So firstly, one project has been established within this community, which is named as Cloud Native OAM. This project is targeting to deliver a group of ONM functions which serves the CNFs. And this group of ONM functions will deployed on a container environment and play as the PaaS services, telco PaaS services. And also everything I will introduce in this session are all about this project. And for this project, we have delivered several functional features. 5 of them are about the telco PaaS functions, and 3 of them are some supporting functions that we used to support provide some supportance for all these telco PaaS functions. And then we also have created some Helm charts for all the above functions so that we can get the cloud native OAM deployed on any Kubernetes environment and Kubernetes and a container environment. And also we have wrote some design guide for the cloud native OAM, which tells you that how we design this system and why we do that, what kind of functions does the system have. And also we wrote a user guide about the northbound APIs here, which tells you all the interfaces that you can use as a management person, or if you have some upper layer management systems. And also we have the installation guide to tell you that how to install all the functions of the cloud native OAM. And also we have achieved that to deploy the cloud native OAM functions onto 2 types of Kubernetes and container environments, which are the Inspurs container platform, which is a commercial product, and also the CMCC's container platform, which is the public cloud product of China Mobile. And also we have done some testings. Mostly of them are like functional testing, the performance testing and some other interactions or collaborations with the real CNF testings are not covered within the last release. So that's pretty much all the review of all the release 11.2022. And then let's look at directly onto the details of the our last release. So within the release, 2 GitHub repos are related to our last release. One is the Cloud Native OAM repo, and another one is the Cloud Native OAM Builder repo. Within this repo, all the functional codes are contained, and within this Builder repo, all the Helm charts are contained. And then let's go into this one, which is the most important one. So here we can see that we have some agent codes, alarm codes, authorization codes, configuration codes, some gRPC communication codes, log codes, and things like that. And then we go to the design doc to give a detailed introduction of what the cloud native OAM is. And for this, I would go okay. So cloud native OAM is actually a group of operation and management functions to serve the network functions. it will so here, if you look at the right picture, the cloud native OEM are the middle parts, and it is used between the upper layer management systems and the cloud native network functions. The upper layer management systems can be, for example, OMC, OSS, or maybe even the ONAP system. And the cloud native network functions currently we used are UPF. If any cloud native network functions, any 5G functions, 5G core network functions are implemented as the cloud native type, it can also use these cloud native OEM functions. And here, for the entire cloud native OEM systems, we would have a northbound API, which provides all the management capabilities to the upper layer management systems, and a group of southbound API, which provides the network functions with a group of like interaction interfaces for the cloud native OEM. And here we use the gRPC to take the to serve the communications, and here we just use the RESTful. Okay, so then let's look at the design principle of it. So for the cloud native OEMs, we have separated all the functions into 3 layers, which are data sharing layer. This layer talks to the upper layer management systems. It is just about the API's exposure. And the middle layer is the OEM processing layer. It contains all the database, all the data processing, and all the like decision making policies and storage and things like that. And then is the OEM agent layer. This layer will like plays as a data collection point for all the network functions, and it will also like it serves the processing layer with all the data collected, and the processing layer will serve the data sharing layer if this layer wants to like get some data or do some operations which has been triggered by the upper layer management systems. So these are the 3 layered basic architectures of this. And then we can look at the functional designs. So the first function about cloud native OEM is the network function register. This function lets the network functions newly deployed or newly onboarded to the cloud, like Kubernetes or container environment, to like establish some connections with our cloud native OEM systems, like register itself to this system, and then our systems will like collect some of the basic data of the network functions, and also our system will like notify the upper layer management systems to tell them that, oh, we have a new network function is onboarded in the whole systems. So here we can see that for each layer, the agent layer about the network function register will provide a unified southbound interface for network function to register itself. And then it will collect some of the network function data and send it to the processing layer for the backend storage. The network function data would include the, for example, the instance ID, the name of the network function, what type of it, the management IP port, and things like that. And then the data sharing layer would this function block in the data sharing layer will monitors the change happened in the backend database. Like if there is a new NF records occurred, it will provide some notifications to this up layer management system through a northbound interface, which is used specifically used for the upper layer management systems to subscribe the NF register notification. And the next function of this system is the network function management system function. So here, this function provides the upper layer management system to establish some management relationship with the network functions. So once the NF is registered to the cloud native OEM, it is firstly doesn't being managed by any upper layer management system. And then this system will use this function to manage one or multiple network functions. So for this function, the data sharing layer will firstly provide some northbound interface for the management system to query that to query target NF data. For example, I received some notifications of the newly registered NF, and I want to check what's the detailed data of that. You can use this interface. And also, if I don't know anything about the NFs, I can use this interface to check what kind of network functions are running within the system, and also whether this kind of those network functions are being managed by some other management systems. And then it will provide a northbound interface for to query the NF microservice topology. So for all these NAVs which are designed in microservice architecture, it will have some have a topology which contains the NF name, NF microservices, and the NF microservice instances. So this topology will show the upper layer management systems about those kind of information. And another northbound interface provided by the data sharing layer is the management function. So it will actually allows this system to manage a network function, and after this operation, it will gain all the management and operation authorizations on a specific network function. And then if we can manage a network function, we can also unmanage a network function. So there is another northbound interface for these management systems to unmanage a managed network function. So these are about the data sharing layer capabilities for the NF management. And then within this processing layer, this layer will accept all the query command from the data sharing layer, check the backend database, and respond some filtered data. And also, if we will accept all the manage and unmanaged command from the upper layer, from the data sharing layer, and update the NF management status in the database. For example, we will take a record for the management systems and also change the management status of the network functions. So these are about the network function management. And the next one is NF heartbeat management. So this is a simple function. It will like monitors the heartbeat generated by the network function. So for the agent layer here, it will collect the heartbeat generated by the NF. And then for processing layer, it will track all the heartbeat collected by the agent layer and also diagnose the NF status based on some predefined rules. For example, if the during a long time, the agent, this processing layer didn't got any like heartbeat update from the agent layer, it will trigger an alarm. And another example is that if the NF is disconnected with the whole system, then the heartbeat will also break. Then the processing layer will also track that status and generate some alarms. And for the heartbeat, there's no data sharing layer capabilities here. The next one is network function configuration management. So this function provide the upper layer management system a capability to get configurations of the NFs and set configurations to the NFs, and also do some rollback on the NF configurations. So for the data sharing layer, this function will provide some provide a northbound interface to query the configuration information of the selected NF. So this interface is usually used when the upper layer management system firstly wants to configure the NFs. So the usually different NFs will have different configuration files, and if the upper layer management systems use this interface to get those configuration files and to know that how to configure the NFs, like what kind of parameters I should give, what how should I set the values, and is there any special instructions on configuring a NF. All these kind of instructions will be provided by this interface. And then there's another northbound interface to synchronize the configuration details. So these are about the configuration files, and then we have a interface to read all the contents and show directly to the management systems. And also another northbound interface is about the management system to send configurations to NF and configure the NF. And then another northbound interface is used to select some historical configurations and roll back the configurations of the network functions. So this system supports to store 5 historical configurations of a certain NFs. So if you want to roll back to some certain versions, you can use this interface. And then for the processing layers for this function, we will maintain the configuration operations and also store the configuration files, all the details about the configuration. And for the agent layer, it will just collect some initial configuration files from the network function and also send the configuration to the NFs and track its execution outcomes. So these are all about the network function configuration management. And another function we planned to implement is the network function signaling tracing. but we haven't included it in this release, so it will be updated in the future. And the last three functions are about observability. The first one is about the network function performance management. So as the Prometheus are commonly used to serve as the backend for performance for metrics collection, here we just chose the Prometheus to implement this function. So here on our agent layer, we will use a exporter for the network function business level performance data. So all the metrics about the resources of the computing resources, the network resources, all of that we will go directly get directly through Kubernetes. But for the NF business data, which is generated within the NF itself and cannot be get by the Kubernetes environment, we will use these functions. So here the agent layer collects all that kind of data. And then for the processing layer, we will like store it's just the Prometheus. We just store the performance data collected by the exporter into Prometheus. And for the data sharing layer, we created a northbound interface for the performance data subscription. So you can somehow you can get the performance data directly from Prometheus, and also you can like get notified every time we collect a bunch of metrics using this interface. And the next one is the NF alarm management. So this is also a simple one. The agent layer will just collect the NF alarms. The processing layer will like process all the alarms and store them into backend database. The processing on the alarms would include like the remove the duplicated alarms, separate the historical alarms and active alarms and things like that. And for the data sharing layer, there is also a northbound interface for the upper layer management systems to subscribe the target alarms of a selected NF. And the last network function is the network function log management. So this is the super simple one. It's just an integration about the EFK. So that's all about the design principles and the functions. And then we can have a quick review on the interfaces. Sorry. Okay, so here, besides all the functional interfaces listed within these blocks, we will have some supportance interfaces. The first one would be authentication and authorization. It will support to issue tokens for the upper layer management systems as long as they provide the username and password. And we will have a interface for the newly registered NF subscription. So with this interface, every time a new NF registered to the system, the upper layer management system will get notified. And this is an unsubscribed data of newly registered NF. So if the upper layer management system wants to stop the subscription, it can use this interface. And also, if a upper layer management system wants to check whether what kind of NFs, whether it manages a subscribed the newly registered NF, it can use this interface. And then is the subscribe business data of NFs. So the upper layer management systems can use this interface to subscribe the alarms or the performance data of target network function. So here the upper layer management system can use the NEID to indicate the target NFs, and the data type here can support the upper layer management system to set what kind of data they want to subscribe. They can use alarms for the alarm data subscription and perf for performance data subscription. And also it will provide some callback URL for the like information callback. And also there is a unsubscribe business data of NFs. And also here, the upper layer management systems can use this link to get the what kind of subscriptions they have made with these cloud native OEM systems. So for example, if the system use this link, this data type shows here will tell the system that it subscribed some register data, alarm data, and also some performance data. And this interface let the upper layer management system to manage a target, manage a network function. For example, you can use indicate. This is you can list the data type by saying that I want to manage a UPF function or an AMF function, and the ID, like there would exist several UPFs here, then the ID will narrow down the management boundary to a single one. And also the system ID will tells the system that who the management system is. And then this is an unmanaged interface. It's quite it's the pair for the management interface. And here we use a flag to indicate that when the upper layer management system wants to unmanage a NF, rather should the cloud native system to delete the NF contents. If you set the flag as 0, we will not clear the NF data. If you set the interface as 1, we will clear it. And this interface is for the upper layer management system to get the NF list. So like you use the link and you get everything about the everything about the network functions deployed within the system. And this API is to get the logs. Then the cloud native OEM will reply the logs. And this link is to get the topology of target network function. So here, the cloud native OEM will respond the topology. And the configuration list, this is to get the configuration list. It will shows you that the versions, the storage path, the name of the configuration files, the size of it, and when does it update it. And for the post configuration, so sorry. Okay, so if the app layer management systems wants to like update the configuration of a nav, it will firstly post some configuration files onto the cloud native systems. So this link is used for that. And then after the system post the configuration onto cloud native OEM, it can like set the configuration of some certain navs. And also this link is to like switch the configurations of the network functions within all the historical configuration versions. So that's pretty much all about the API introduction. As the time is limited, I will not go through the demo of it, but because we have some record on about the demo that we have given to the XGVela teams, you guys can go to the XGVela wiki page under the TSA meeting minutes and go to the TSA minutes for October 25th last year to have some to have a look at the demo, which is the meeting record here. I will give the link to the okay, to the chat. Okay, so that's pretty much all about the session. Thank you guys for listening. If you have any questions, you can directly contact me through email or Slack or somehow. And also, you can go to the XGVela wiki page to check the detailed contents about the release 11.2022. So thank you guys for listening. That's all for the session.
Thank you, Chewy.
Thank you.
Thank you, Chewy.
We are
Yeah.
a little over time, but do we have any quick questions for Chewy?
Oh, yeah. Okay. I
Okay,
think no
then.
more questions. Great.
All right. Thank you.
Thank you. Have a nice day.
Take care, Chewy. Take care, everybody.
Yeah, enjoy the event.
Bye, everyone.